Alright, so hello and welcome. Oh, look at this. Look at the sun is right in my eyes now. So, had some food, took a shower, feeling great. Feeling great. So, we got more problems to work on. So, keep going. So, we'll keep going. Let's do it. Let's get into it. Look at this. I'm gonna get a tan, man. Gonna get a tan if I keep doing this. So, alrighty. Let's see. Problem we're working on now is insert, delete, and get random O of 1. So I think I have an idea of what this is, what they're expecting, and how to implement it. Have an idea. Give me just one moment though, I want to check something. Yeah, okay. Okay. Yeah. Implement the randomized set class. Randomized set initializes the randomized set object. Bool insert int val inserts an item val into the set. If not present, return true if the item was not present, false otherwise. Remove this value removes an item val from the set if present, return true if the item was present, false otherwise. GetRandom returns a random element from the current set of elements to guarantee that at least one element exists when this method is called. Each element must have the same probability of being returned. Okay. So most 10 to the 5th calls will be made. So remove GetRandom. There'll be at least one element in the data structure when the random is called. Can you implement the functions of the class that each function works in average O one time? The functions of the class that each function works in average O of one time? Well, yeah, I was going to do that. I was going to use a hash set to do amortized constant time. So, yeah, we'll do that. Yeah. So we'll use, we want unordered set. Yeah, I'll explain what to do. Basically, we're going to use an unordered set, and then we're going to use a, is it random? I always have to check this. Excuse me. It is random, okay. And I want the twister. We want the twister. We're gonna use the built-in library to do this. Random device. Let's get an example again. Uniform int distribution. This is what we want. All right. Yeah, we're gonna use. Yeah. We're gonna use the randomization library to implement this. Show you what this is gonna look like. So we're gonna say elements. Randomized set is really not gonna do too much here. I think we have an engine. So we have a random device R. We have default random engine. Is that how that works? Do we need that? Can we just use, wait. Hold on. Give me a second here. Oh, I see. This is the generator. Okay, got it. And then you use the generator to, okay, got it. It's a little confusing, but got it. There's MT, what do we say for this? MT19937. Is that 99? Yeah, 99. Gen. And then may or may not be able to do it this way. Random device, generator, and then we're going to use an unordered distribution, or yeah, uniform distribution. Uniform int distribution, which is going to be, just say distrib D, and then we're going to define each of these in the randomized set. Tricky thing about this though, well, we can update the parameters for the distribution as we go. So, okay, so we're going to say, excuse me, so gen is going to be equal to MT9937 of, and use R as the constructor, and then D is going to be something like this, of, the parameters are just really 1 and 1 at the moment, initially, or yeah, just 1 and 1, we'll say. Could be 0 and 0, really doesn't matter. And then that's really it. This doesn't really matter that much, actually. The generator kind of matters, I guess. Yeah, okay. And then when we insert the value, we said, I'll explain all this as I go, and I'm also kind of hoping this compiles and works properly. So insert into the set if it's not present. So we're just going to check, bool check is elements dot count of val. So inserts an item into the set if not present. Not check. Then elements insert val. Really doesn't matter. You don't need this. You don't need to do it this way. Because even if it is present, it's just going to overwrite it. Doesn't really matter. If the item was not present, return true. So check is not. So if the count is 0, and then I'm going to say true. Okay. Remove an item if it's present, turn true if it was present. So yeah, it's a little confusing, but same deal here. May or may not actually need to, what do they call that? I think it'll automatically, these are both integral types of bool and an int. So I think it'll automatically typecast. Excuse me, but if it doesn't, then I may have to add that. But yeah, so elements count, check, removes an item if present. So if check, and then we'll return check. Yeah, this is basically this function is idempotent. It won't do anything if it's already sort of set. This one, on the other hand, does matter if it's there or not. Excuse me, if it's not there and you try to erase it, it'll cause problems. So I want to add a branch there. And then yeah, remove, insert, and GetRandom is kind of the interesting one. So, oh, when we insert, we also want to update our, might as well do this, fine. Check. just because we're going to add some extra functionality in here, dependent on whether or not we should add something new. So we're going to take our d.param, and there's a way to do this. I forgot how you do this. No, hold on a second. Oh no, that's not what I wanted. Okay. Yeah, so you call this function with this type params, which is you construct it with the parameters. It's a little confusing, but so we're going to say auto new params of 1 to elements dot size, and then you're going to say d dot params of new params, something like this, right? And then same thing over here when you remove an element. Yeah, this is the same code. Okay, and now when you're down here and you want to get random, you're going to get a pointer is going to be uniform int distribution. No, it's going to be the beginning of elements. You're going to say int random, or just, I don't know, x, we'll call it. And that's going to be this distribution D of this generator that we're going to use, gen. Now, I don't know if you call this, I don't think you call the generator, I think you just use the generator as a parameter. And then now you're going to say standard advance pointer by x, return x dereference, something like this. I think it's also size -1 too, by the way. I actually think this is supposed to be 0. Yeah, I made a mistake. Okay, so it's kind of a lot going on here. Not too much, but basically we're trying to make use of the uniform int distribution class built in. What not allowed in non-static? Oh, int. Duh. Yeah, it's the int type. It's a little confusing. I realize it's the uniform int distribution of int. However, there are other integral types, and int is kind of just referring to integral type. So yeah, I really realize that's confusing. New params, the type auto contains multiple expressions. Yeah. There is a thing here you can do, which is, this happened to me in the past where I couldn't quite get the full type using auto. I couldn't get the type using auto. It's really annoying. The compiler gave me some issue. Is that an object argument? This is very confusing. What's wrong? What? Does it just give me a hard time? Let me just make sure everything else is okay. Make sure that it's indeed this parameter thing here, which the documentation is kind of spotty. Oh, sorry. Apologizing to nobody here. Apologizing to the compiler because of the confusion. Right, so we want to get these new parameters. Why is this not working? Expected a. This is very confusing. It is param. Manages the associated distribution parameter set. None, return value, associated set. So you can call the function param, and there's param type, that's what it is. Yeah, see that's nice. 2 params, yeah. So you would call param, not params. And what is this? This is very funny. This is I want to say param type. I don't even know. The new params. Oh, you're kidding me, really? Excuse me. That is so funny. Yeah, this is like the most annoying thing. Or this is annoying to me. Can't just use auto for this. Just doesn't type deduce. It's like, okay, multiple expressions. I think because they both have to need to be integers. I think that might be it. It's because this is a different type. Can we do this? Multiple type expressions. Can we do? This is a funny thing. Yeah, A, B. Look at this. Okay. The A and B are parameters. As a parameter object. It's so confusing. It's very funny though. Not funny, but like it's, I don't know. I don't know what to say about it. But like I can't just get the parameter object here. It's so annoying. Alright, if we do, because if you do just auto params, right? Like I think the reason, it's kind of funny. It's like, of course the compiler is not going to be able to figure out, how is the compiler supposed to know that this is the object that's being referred to here when all you're doing is calling it with like 2 integers. Hello? If you just say auto params, it's like, what is that object supposed to be? Yeah, of course. That's why it's so annoying, because it's like, it's one of those objects that's just, there's no way to deduce what this is supposed to be, and it's like this whole mess of like uniform int distribution int param type. That's the whole object name. It's like comically, it's kind of comical. Just say that. It's kind of comical. You can tell I've done this before. This is not my first rodeo here. I've done this before. Just thinking, kind of want to do it the correct way, whatever that is, whatever that might be. All right, let's go for it. Let's go for it. Let's be bold. Oh wow, we got it. All right. Yeah, I wouldn't normally recommend doing that. Yeah, if you do what I just did there, it's very likely that you're gonna get the wrong answer. Don't do that. Don't do what I just did. All right, 19 minutes, not too bad. Yeah, it was okay. That was okay. Took some time. All right. So pretty simple, really simple terms. Like you could express this in another way. Like let's do it from a high level. It's just using the random library to get random numbers from a uniform int distribution, and using the unordered set to maintain our set. and you kind of just do what they ask. If you for inserting, insert something into the set, removing, you remove it from the set, and you want to update your parameters for the with the random number generator, so that way you get the right distribution, you get the right set of numbers to get random things from. So when you later, and you do that, and you just update to what the new size of the set is, whatever that might be, those parameters. That should be constant time, and then no, it doesn't constant time to do that. And then when you get a random element, you're going to get a pointer to the beginning of the set, random number, so basically an index into the set, and then advance that beginning pointer to that index, which was a random index, and that'll give you a random element. Return that. So really simple overall. Yeah, super straight. Should be like super straightforward. So yeah, hopefully that was interesting. That was definitely interesting for me. I'll say that, because I've messed around with the random generator, the random library, and that particular. Also, I'm gonna just lower the volume a little bit too, because it's a little loud. Yeah, that particular function is definitely interesting to me. Yeah, it's fun. That's a fun one. Let's see, wait, do I have my hair? It's like, I feel like my hair, I'm losing my hair, you know? It concerns me. Concerns me. It shouldn't bother me at all, but yet it does weigh on my conscience. But yeah, that's it, I think, for this one. That's it for this one. We'll go on to the next one shortly. So thank you for watching, and I will talk to you soon. Take care.